behalf of Excelsis Medical and LC, I'd like to express my sincere gratitude for Dr. Sun, Dr. Wu, and Dr. Lee, Eric, for coming all the way from China and Taiwan to join the session here today. 谢谢, thank you. So now our team LC will introduce all of our lab, and I hope today's session will be fruitful and beneficial for everyone in this room. So without further ado, let's deep dive into LARC. It's an abbreviation of laser asymmetric remodeling keratectomy. It's a next generation corneal remodeling technology to treat conical cornea such as keratoconus and keratoconus suspect. These two pictures show a recent surgery we had for a patient with ICRS in the past. With Micronem 7, we performed translator without the removal of the implanted cornea. We'll play a short video clip of the surgery later in the speech. As you may know, LARC is a surgery method that utilizes intraocular pressure, IOP, to achieve corneal remodeling. Laser ablation is done to make symmetric cornea in thickness. Then IOP redistributes the posterior corneal bone to the central area. As a result, protruded area is lowered and corneal shape becomes central symmetry. Corneal protrusion occurs when IOP pushes thin parts of cornea. So if you want to lower the protruded area, both sides weight or thickness need to be equal, just like a seesaw. But if you ablate the protruded area, thin part becomes even thinner, and it will result in a bigger protrusion. Until now, conventional treatment methods for conical cornea treatments were only treating symptoms such as ectasia, high aberration, and dry eyes. In comparison, LARC is not only effective for remodeling the conical corneal shape to a normal shape, but also treat the root cause of symptoms. There's not enough data in this market because there hasn't been enough medical research in this topic. But we do know the market is huge. Treating severe dry eyes did not have a clear solution until now, but LARC is creating a new opportunity for treating severe dry eyes with corneal remodeling. LARC's corneal remodeling happens in 4 phases. 1, ablation of thickness deviation removal. 2, ablation of the spherical aberration to offset the myopic shift that occurs from phase 1. 3, IOP forms the central symmetric corneal shape. 4, there is no change in refractive power before and after the surgery. Ablation for thickness deviation uses a pattern that is used for semi-astigmatism correction. Like the picture on the right, it's an ablation pattern that corrects only one side of the astigmatism. By combining the multiple ablations of semi-cylindrical correction, we can create a customized ablation pattern for thickness deviation removal. When thickness deviation ablation is done, the corresponding semi-cylindrical is corrected. This corrected semi-cylindrical ablation is naturally converted to spherical aberration over time as corneal remodeling happens. The value of myopic spherical aberration is 1/4 of of corrected semi-cylindrical according to the SER formula. So 4 diopter of semi-cylindrical is equal to 2 diopter of cylindrical, and is equal to 1 diopter of spherical. So to sum up, as we can calculate myopic spherical aberration, we do the ablation for thickness deviation removal and ablation to offset myopic shift spherical aberration simultaneously. This is how the corneal remodeling is achieved without a change in refractive power. The effectiveness of LARC was first published in a paper in 2019 by Dr. Agudo from Germany and Dr. Sung-Soo Lee's clinical trials in Jinju, South Korea. The title, Laser Asymmetric Ablation, describes the method of the surgery. And our goal is to remodel the corneal shape, and that's why we have added RE in the naming, and that's how we came up with LARC. In this paper, we reported how the surgical plan was aligned very precisely to the actual ablation of the surgery. I'll leave it on just for a few seconds in case you're looking at the numbers.
Is it performed on human?
Sorry?
Performed on human eyes?
Yes. It's from the paper that was published in 2019. As you can see, the corneal shape has progressively improved over time. We use smear effects, and we have confirmed the posterior corneal bone is redistributed to the central area. And the apex point is closely aligned with visual axis. We have also confirmed that the thickness deviation is reduced and the corneal shape has improved to be more central and symmetrical. When you look at the annual publications, the initial purpose of LARC was for treating presbyopic correction. And then it has transitioned to use for LASIK and LASIK, and then corneal remodeling. This transition over the last few years of clinical trials shows that LARC has been proven as an exclusive solution for treatment of keratoconus with corneal remodeling. So I'd like to invite Gina up to the stage, and she will continue to talk more in detail and how doctors can use LARC in real practice.
Okay, so I want to start off by referencing two papers published in ophthalmology at The Ohio State University. And she emphasizes the need for customized laser refractive surgery based on corneal biomechanical properties in order to predict and control the final corneal shape as well as visual outcome. The reason behind this is because with topography-guided treatments, wavefront-guided treatments, they all experience corneal deformation after surgery due to intraocular pressure. So I brought up intraocular pressure in the previous slide because that's the key to what makes all the difference. If you look at the topography-guided treatment, the idea behind this is to eliminate refractive deviation, whereas in comparison LARC, it's to eliminate thickness deviation. And because of this difference, if you look at the postoperative outcome, regression occurs with topography-guided treatments because there's postoperative change in corneal shape because of intraocular pressure. But that same effect of intraocular pressure, when it comes to LARC, Because thickness deviation was eliminated, the corrective effects are achieved and well maintained after surgery. So I want to now walk you through how the ablation patterns are actually created for LARIC. So first we review the patient's topography maps, and then second we calculate the thickness deviation of the cornea using our software vision app. Once that is done, we establish the ablation pattern to eliminate thickness deviation, as well as an ablation pattern to eliminate the predicted myopic shift that would be caused once thickness deviation is removed. For the actual surgery, we combine these two patterns to come up with the final one, like on the right. So we don't have to perform two different surgeries, and we combine it into one. I'm going to show you a recording of the process that I just explained. It's going to show you these two ablation patterns and how it's combined to create the final pattern. So on the right, you'll see the two patterns being combined for the final surgery. So I want to briefly talk about a case with a keratoconus patient. This patient had ICRS implanted previously at a known eye clinic in Korea. The surgery itself was successful, but refractive error was severe, so it caused irregularity in visual acuity, as well as unstable tear film. So the patient came to us to get LARIC for a follow-up treatment because of these problems. Let me also show you a simulation of how the ablation pattern was created. And because this patient was keratoconus, only thickness deviation was removed without the estimated myopic shift. And I'm going to show you another video of the actual surgery that was performed. So to close off, I want to briefly just walk you through 3 other keratoconus treatments that we have. The first one is a surgical technique by Dr. Carriazo from Colombia. Basically, with this technique, a crescent-shaped segment of corneal tissue is selectively ablated using an excimer laser. The problem with this technique is that it's a non-quantitative method. Second one is a technique invented by Dr. Susan Jacob. She's an ophthalmologist based in Chennai. And for this technique, it involves implanting ring segments made from donor corneal tissue into the stroma layer of the patient's cornea. Again, the problem with this technique is that it's a non-quantitative method. And lastly, it's a study done by Dong and others at the Jinan Minshri Eye Hospital. It's a femtosecond intrastromal lenticular implantation combined with corneal cross-linking. And again, this is a non-quantitative method as well. So all these 3 methods that I've just explained are all non-quantitative methods that's used to treat keratoconus. So that means when they're combined with LARIC, it's going to maximize their effectiveness. So that's all I prepared. I want to thank everyone for their time and their patience. If you have any questions or suggestions, please let us know. And myself, June, KS will be happy to answer.